Hello sir, can we start solving single element in assorted array problem? भाई मना भी कर दोगे तो भी सॉल्व तो करेंगे. ठीक है चलो. So let's read the question once and then we'll start. Okay. So you are given a sorted array consisting of only integers where every element appears exactly twice. Okay. Except for the one element which appears exactly one. Got it? Return the single element that appears only once. Got it? Your solution must run in log n time and order of one space. Okay, so we are given an example that is 112 334488. Okay, and 2 is just one time, so the output is 2. If we see here 3377 10 11 11 and 10 is just one time. Okay, now first thing, that array is sorted means we can think of binary search. But before going to binary search, we'll be analyzing what will be the worst case to find that single element, right? How we can find that single element? We can iterate through array, and the one element which is present once only, that we can count, right? Means we can store the count of each element. Let's say count of element 1 is twice, all good. Means we don't need to store actually. Means we'll be iterating this index and then this index, then just means we'll be skipping one index every time, and we'll be analyzing if two index are equal or not. If these two index are equal, if not equal, then for sure we can say that 2 is one time only, not twice. So that is one way to solve. And with that solution, basically we'll be iterating the whole array, means order of n time, and we are not taking any extra space, so that will be of order one space, right? How we can optimize that? Or is there any other solution possible? Yeah, there is one more solution possible, that we can do XOR of each element, and at the end we're left with one number that will be the number which is present once in the array. The twice present elements will be cancelled out. So what will be the time complexity of that approach? That approach will be of order n, and space complexity is order 1. Now we discussed two solutions. Is there any other solution to solve that problem, right? And we previously think of binary search as well. So what we can do, is it possible to apply binary search on this problem statement? Let's see that. Okay, so I'll be moving here and writing the test case, and we'll be solving that out. Okay, so the test case was 1 1 2 3 3 4 4 8 and 8, right? Zeroth index 1 2 3 4 5 6 7 8. Okay, so what we need to do for binary search? One thing, right? We need left pointer, we need right pointer. What we are going to do next? We are going to calculate mid one. What will be the mid of 0 plus 8 by 2? That will be this one. Now, if you find mid will be either even index or odd index, right? So in case of, let's say, 4, we found 4 here, fourth index, that is even index. In case of even index, what we need to do? We need to check for the next index. If that index value is equal, then till this point, till the third index, everything is okay. I'll give you an example. Let's say instead of this original array, the array will be like 1 1 2 2 3 3 4 4 and 8. In this scenario, if you see mid is fourth index and you encountered 3, you'll be checking next element. If next element is equal to 3, it means you can say that this much portion is valid. Our answer will be from this point. You can shift left here and you can keep your right here. That is one way, right? What if the other way? That is the original case. Now, if you see that at fourth index we got 3 and we checked to the fifth index, and at fifth index that is not equal to 3, means 3 is not equal to 4. So what we need to do, we need to move to this direction, means our solution will be within this direction, that is left direction, right? Okay, so uh, now where to move, means we need to move our right to which index is the question, because match is not happened. So can we move our right, this is left, this is right, and this one was mid element. What if you move your right to mid index? Because 3 can be the answer, right? Why 3 can be the answer? I'll show you. In case the array is 1 1 2 2 and 3, then 3 might be in our answer, right? 3 can be the unique element. So we'll be moving our right pointer to mid. Now let me write the cases. Okay, so let me write the initial case. If you found mid and mid is odd, so we need to perform some operation, right? I'll be moving it here. Okay, and else we need to perform some operation. That is, our mid is even, right? I can write here mid is even. Now, what is the case? In blue wala case, if you see that in our particular case, if mid is equal to fourth, that is even case. Now, in this scenario, I'll I'll do one thing. I'll create scenario for each. Okay, let's say you are having an array that is of 0 1 2 3 4 element, and you found even index, and your answer is at the right hand side. Okay, so let's say 1 1 2 2 and 3 is your array. So what you can do, mid, you check mid is equal to the right one. If value at mid is equal to value at mid plus 1, right? If that is the case, then your answer will be at left is equal to the mid element plus 2, right? Else your right will be shifted. Now, how right will be shifted? Next case, with same example, let's just 0 1 2 3 4. Now, if you see 1 is 1, let's say these are same. Okay, now you encountered this and you found out that it is no more equal, right? So what you are going to do, you are going to shift your right to this position, means 2 can be your answer. So right is equal to mid element, right? That is the case. Okay, now if let's say right got shifted here, now this is left and this is right, you discarded this portion. Now what will be the mid? Mid will be this. Now mid is odd and it is equal, right? Now mid is odd and it is equal to the just right element. If mid is odd and value at mid is equal to, just a second, system got slow. Okay, mid plus 1. If that's the case, then what you are going to do? It means if right element is equal, it means your answer is within left side, right? So you can move your right pointer to mid minus 1. Okay, else what we need to do? Okay, we'll see if the other case here, in this case, our this was the case mid plus 2 if equal. What if not equal? Even and not equal. If not equal, then answer will be at this side, but equal means answer will be at this side. Okay, so left and right will be here, and the solution will be available. Now we need to create one more case, that is, let's say 1 1 2 3 3 0 1 2 3 4. This one is left, this one is right, and if you see this one is mid, and this one is even case and it is not equal. If it is not equal, then what we are going to do, we are going to move our right index to mid, right? So this will be boiled down to 1 1 2, and left is here, right is here, 0 1 2. Now mid index will be at this, and if you see, mid index is not equal to mid plus 1. If it is equal, then we are going to move right. If not equal, then we are going to move our left pointer, that is left is equal to whatever the mid plus 1, mid plus 1. Now every time your algorithm will be like ending at some position where left and right will be equal, that at that point you'll be getting your answer. Okay, so this is what the algorithm is that we need to implement. Here you got the pseudocode, right? The same thing we need to implement, and I guess this will cover all the test cases and edge cases as well. So yeah, we can go ahead and code that out. Okay. Okay. So let me bring my laptop closer. Now, what we need to do? We need to first left pointer, right pointer. Left will be pointing at 0. Right will be pointing at length of nums minus 1. Right. Now, while left is less than right, what to do in this case? We need to calculate mid, right? Mid element is equal to, we can do left plus right minus left by 2. You need to do you need to do this when there is a case of overflow. Means in CPP or some other language you're using, then use this one. It will save you from overflow. Okay. And but in Python you can just use left plus right by 2. That's same. Now if mid mod 2 is equal to what? If let's say, oh, just a second, here mid is odd, means the 1, right? If that is the case, then what we need to do, we can see if mid is equal to mid plus 1, we need to compare. If nums of mid is equal to nums of mid plus 1, yeah, we need to take care of that mid is never getting overflow or underflow, means not going beyond left or beyond right. Okay, that will take care. Okay, so if this is the case, what we are going to do, we are going to move our right pointer to mid minus 1, right? Right is equal to mid minus 1. Else one, what we need to do? Else we need to move our left pointer to which position? That is mid plus 1 position. Mid plus 1 position. Okay. Now, else, the other case, I'll just copy this case because we are going to write this case only. Now here, if you see, if that is the case, then we need to move our left pointer to mid plus 2. That left pointer is equal to mid plus 2. Okay. And right pointer to the mid value. Now, at the point where left and right will collide, will give us the number. So what we can do, return nums of left. Okay, so that will work. Now, let's say we have just one element that will show short work. Left and right are at same position. Now we have, let's say, three elements, right? In three elements, we have covered some example, like if this is the three elements and it is on the right, so left will be moved towards here, right? And in case of these three elements, uh, right will be moved to this position, means odd case, and yeah, odd case, and it is equal. Equal means right will move to mid minus 1, so 1 will be the answer. Okay, so I guess the edge cases are getting covered with this. I'll just try run it and see if that is working fine or not. Okay, in case of any error, we'll go through it once again and see. All good, it worked. So now let's analyze what's the time complexity. Time complexity of this code is like, you see, we are dividing our search space into two half. That is, uh, yeah, into half. And whenever the mid index is the odd index, then we need to perform this operation, else we need to perform this operation that we already discussed, right? And it's a space complexity, if you see, that is left, right, and mid pointer only, nothing else, right? So space complexity will be order of 1, and the time complexity is n log n, that is satisfied. Okay, so that's it for this video. We'll see you in next. Thank you.